Now that we have reviewed the basics of a blockchain and its basic structure and origin, let's consider the basic operations in a blockchain. Operations in the decentralized network are the responsibility of the peer participants and their respective computational nodes, for example, laptop, desktop, and server racks. These operations include validation of transactions, gathering the transactions for a block, broadcasting the valid transaction in the block, and consensus on the next block creation, and chaining the blocks to form an immutable record. In this lesson, we explore some of the fundamental operations of the Bitcoin blockchain. First, we have to discuss the participants. There are two major roles for the participants. Participants that initiate transfer of value by creating a transaction, additional participants called miners who take on added work or computation to verify transactions, broadcast transaction, compete to claim the right to create a block, work on reaching consensus by validating the block, broadcasting the newly created block, and confirming transactions. You might wonder why a participant would take on additional work. Well, the miners are incentivized with Bitcoins for their efforts in managing the blockchain, as we'll find out. Transaction validation is carried out independently by all miners. The process involves validation of more than 20 criteria, including size, syntax, etc. Some of these criteria are referenced input unspent transaction output UTXOs are valid. Recall, UTXOs were defined earlier in lesson 2. Reference output UTXOs are correct. Reference input amount and output amount match sufficiently. Invalid transactions are rejected and will not be broadcast. All the valid transactions are added to a pool of transactions. Miners select a set of transactions from this pool to create a block. This creates a challenge. If every miner adds the block to the chain, there will be many branches to the chain, resulting in inconsistent states. Recall that blockchain is a single, consistent, linked chain of blocks. We need a system to overcome this challenge. The solution? Miners compete to solving a puzzle to determine who will earn the right to create the next block. In the case of Bitcoin blockchain, this puzzle is a computational puzzle and is central processing unit or CPU intensive. Once a miner solves the puzzle, the announcement is broadcast to the network and the block is also broadcast to the network. Then other participants verify the new block. Participants reach a consensus to add a new block to the chain. This new block is added to their local copy of the blockchain. Thus, a new set of transactions are recorded and confirmed. The algorithm for consensus is called proof of work protocol, since it involves work or computational power to solve the puzzle and to claim the right to form the next block. Transaction 0, index 0 of the confirmed block, is created by the miner of the block. It has a special UTXO and does not have any input UTXO. It is called the coin-based transaction that generates the miner's fees for the block creation. Currently, the miner's fees is 12.5 BTC for Bitcoin. This is how new coin is minted in Bitcoin. To summarize, the main operations in a blockchain are transaction validation and block creation with the consensus of the participants. Yet, there are many underlying implicit operations as well in the Bitcoin blockchain.